The skill we're going to be working on today is estimating square roots and using that to help us with Pythagorean theorem. So one of the things that we can use to help us visualize is a simple number line. So what I want to do is, on my number line, add a couple of key pieces of information. On the bottom of my number line, what I want to do is create the whole numbers, or a number line using whole numbers, to help me visualize where things are going to be located. I'll make mine all the way up to 10. What I actually want to add on the top of my number line are the associated square roots. So what I mean by that is, we know that 0 is the square root of 0. We know that 1 is the square root of 1. 2 is the square root of 4. And we can keep on going all the way down. So what we're working here with are squaring our numbers underneath in green to help us give us the equivalent square roots on top. So now that we have that information down, we can try and place our square roots here. So if we were looking for placing the square root of 2, I can think that, or look to myself on my number line, it has to go between the square root of 1 and the square root of 4, but it's going to be a little bit closer to my square root of 1, so I might place it somewhere about there. And I can cross out that I've completed that one. Take a moment and finish the rest on your own. So what you can see is the approximate locations, or the estimated locations of each of those square roots. If you need to pause the screen to double check your answers, feel free to do so before moving on to the question below. Now when we visualize on grid paper, or when we visualize on a number line, this is going to help us estimate again and put into our mind how things might be spaced out on to our grids. What I have here in my small orange square is a measurement of 4 squares by 4 squares, so I know that that's going to give me 16 total area. What I have on my larger set of squares is 5 by 5, so this is going to give me a total area of 25. So if, for example, I wanted to find the square root of 20, what I need to think about and estimate is between the 4 and the 5. This is similar to a number line, just a different look at it or a different view. How close would it be? So I know that 20 is a little bit closer to 16 than it is to 25. So I can say that it's a little bit under halfway. And I can just kind of sketch in approximately where I think it would be. Now if I was to figure out each of these side lengths that I now have in green, I again know that I'm looking to figure out the side length, the square root of 20. And if I was to estimate that, and I'll put that little dot on top so that I know that it's an estimation, I would say that it's approximately 4.4. Again, I know it's not going to be 4.5 because 20 is not exactly in the middle of 16 and 25. So I know that it needs to be a tiny bit less than that. On the bottom of my page, we can use our estimating skills again to deal with some larger numbers. Again, a good suggestion is to create your number line. This time, based on the numbers that I'm going to use, I'm actually going to start with 3. And I'm going to skip a whole bunch of places and fill in my number line. What I want to put above each of these is what that is equal to in terms of its square root. So I know that 3 is the square root of 9. And after taking a moment to fill in my number line, I'd suggest maybe skipping 2 or 3 of the dashes per time to make sure that you can fit everything in nice and evenly. Put your square roots, or estimate your square roots, onto where you think they should go. We'll come back and check in a second. So what I have written in purple are my estimates of where each of those square roots will be placed on that number line. Again, it's important that you estimate to approximate, or to 1 decimal place, and some of your estimations will be plus or minus maybe 1 decimal place, but we'll get better with that as we continue to practice. And this is a perfect example of knowing your squares and square roots and multiplication facts is going to make this a little bit easier for you. All right, what this is leading us to is to use the Pythagorean relationship or the Pythagorean theory, or as we'll start calling it, P theory, a little bit easier to keep track of, so we're going to just keep on calling this P theory, to help us determine properties or side lengths of right triangles. So the key thing here is that we do have to make sure that we have a right triangle. Now we know from our previous unit that in a right triangle, we have a couple of key components. We know that we obviously have our right angle, which is right there. So this is important to be able to identify. And the other thing that is important to understand is that we have 3 side lengths, or 3 variables that we can use for each side. Typically, we call the bottom of our triangle side B. That's just something we've been used to saying. What we're going to change, however, is that the upper part, or the vertical part of our triangle, is now side A, and the last component is side C. Now, side C actually has a special name. It's known as the hypotenuse, and it is always going to be the longest side of our right triangle. What we can use to help us find the hypotenuse is locate that right angle, draw like a little arrow through from the corner, through the corner of the right triangle side, and then like a little arrow, and whatever is opposite that right angle is going to be identified as our hypotenuse. Now, what the Pythagorean theory tells us is that if we use this formula, c squared equals a squared plus b squared, we're going to be able to determine the missing sides. So in the case of the triangle that we have up above, we can see that side B is 3, side A is 4, and in this case we're already given side C, but we're just going to show how this works out. So if I take my Pythagorean theory and rewrite it, so c squared equals a squared plus b squared, I just have to do a little bit of replacing. So the value of c for my triangle is 5 centimeters. I'm going to square it. The value of a is 4 centimeters. I'm going to square it. And the value of b is 3 centimeters. I'm going to square it. Now remember, what we're trying to do is not actually solve for any missing number. We're trying to use our equal signs to make an equivalent, so that what we have on the left side of our equal sign is eventually equal to the right side of our equal sign. So here we have 25 when we square that out. We have 16 and we have 9. So we can see that our left side is equal to our right side when we add together. This is important in knowing that these measurements, 3 and 4 and 5, are accurate. So just to recap really quickly, side C is always the longest side, and we can say that this is also known as the hypotenuse. And side A and B are the other 2 sides, or the other 2 legs. So the first example we'll do together. And before we start, again, it's important that we take a second and create a little chart to identify our side lengths and our variables. So we know that in our triangle we have side A, we have side B, and we have side C. In this particular case, we can see that side A has a measurement of 4, side B has a measurement of 4, and side C is actually unknown, or that's what we're going to go looking for. So now we can use our Pythagorean theory to help us calculate and estimate the length of this side. So c squared equals a squared plus b squared. Then what we're going to do in our second step of math is replace our variables. We still don't have anything for c, so we're going to leave that by itself. We know that a has a value of 4. We're going to square it. B has a value of 4. We're going to square it. Still don't know what c is, so we have to leave that as it is. 16 and 16. We know that c squared, when we add those 2 together, is going to give us a value of 32. Now, what we have to focus on, and now what we have to do, is we have to get c all by itself. So we remember from earlier in the week that the opposite of squaring something is finding its square root. So by finding the square root of c squared, and if I do that on the left-hand side of my equal sign, I also have to do that on the right. So I'm going to find the square root of 32. When I simplify that down or divide that down, the square root divided by the square is going to leave me just with c, and when I find the square root of 32, I can do this a couple of ways. To start out, if you want to use a calculator, that's no problem, but it would be best if you can start to use your estimating skills to help you out. So if you're estimating this, you hopefully will estimate it out to be approximately 5.7. If you are using your calculator, you will have calculated out to be 5.65 and then a whole bunch of decimals. So again, we want to make sure that we round that to one decimal place. So our approximate length of side C is going to be 5.7 centimeters. Take a moment and try the rest of the questions on your page. All right, now the trick to all of this is making sure that, just like you've done with other things in your math career, you don't just randomly put things into random spots. You have to make sure that you're replacing the appropriate variable with the appropriate number, and that each part of your shape, in this case as a triangle, is called the appropriate thing. So in this particular case, side B is what is missing, side A is 5, side C is 10. We write out our Pythagorean theory exactly the same as we've learned. We insert for the numbers that we know. But once we have multiplied out or squared out, what we're left with is this b squared over here. Now it's important that we not just randomly switch our formulas and our equations around, but that we take our 25 and we move it to the opposite side of our equal sign. We know that when we move something from the left side to the right or from the right side to the left, that it becomes the opposite operation. So instead of this being a positive 25, it's going to move over here and become a negative or a minus 25. And once we complete and find that 100 minus 25 is 75, we again square root both sides, and we're going to get an estimated side length of 8.7. The one thing we also want to double check is if this is what we have determined or calculated, that if we were to put it into our shape, we do want to make sure that that seems logical. And the easiest thing to do is, and the most appropriate thing to do, is to make sure that it is smaller or shorter than the hypotenuse. Remember, hypotenuse always has to be the longest shape. So the fact that this is 8.7, we can be pretty confident that we're on the right track. If we had calculated this, however, and our base or side B had a measurement of 12.2, that's a bit of a problem because we know that we are being told that our hypotenuse, which has to be our longest side, is 10. So that cannot be the case. We have to maybe go back and take a look at that. Let's take a look at our questions down at the bottom. Very similar, all right? We have to make sure that we identify side A, B, and C appropriately. Make sure that we put it into our formula appropriately. Make sure that we calculate appropriately, and make sure that we estimate appropriately. So for example C, you have an estimated side length of 19.1. Again, knowing that this side now has a measurement, or we've determined that this side has a measurement of 19.1, that seems reasonable because it is longer than our other two sides. Finally, when looking for side A, same thing. Write out your little chart, figure out what your variables are, make sure that you keep your Pythagorean formula exactly the same, make sure that you replace and move things appropriately. So in this case here, I've taken my length for side B and I've moved it across my equal sign. When it moves across, it becomes a negative. And once I've done the rest of my calculating, I figured out that side A has an approximate length of 23.1. What I again want to check that against is my hypotenuse and make sure that it is, in this case, smaller than my hypotenuse because I've been given that information.